Let's get started. So my name is Dmitry Jemerov, and I work as the lead of the tools team working on Kotlin. So my responsibilities include the IntelliJ IDEA plugin, build tools like Maven and Gradle, and other related stuff like Android development tools. And as someone who works on inspections in IntelliJ IDEA, which are one of the tools that help you change your code into the idiomatic style, I'm kind of responsible for formulating what this idiomatic style is. So how you can use Kotlin not just as a different version of Java, but as a language that provides its own flavor of code and its own benefits, and so how you can use those benefits in the optimal way. And today I'm going to show a bunch of examples showing different features of Kotlin that many of them you probably know about, some of them probably not. And I will also demonstrate IntelliJ features which let you convert your code into a more maintainable and more idiomatic way. So with that, let's get started. So I have arranged my talk like by levels of features. So I'll start with like the lowest level of the individual expressions. Then I'll move a level up to talk how you can define classes and functions in Kotlin and using these features in idiomatic way. And finally, I will talk about some of the standard library functions that help you convert your code into a more idiomatic form. So let's start with the basics. So as you know, in Kotlin you can you can define functions with either expression bodies or block bodies. And a function with an expression body function with a block body is just like a Java method which has a return type and return statements in it. And the expression body allows you to omit the return statement and just put the function body as a single expression. And many statements in Kotlin, which are just regular statements in Java, can also be used as expressions, and when is one of those statements. So in this example, so here you can see that we have defined a function that returns a value depending on the input parameter that has been given to us. And this is how you would write this function in Java, and in Kotlin you can actually do better. You can just turn the entire function body into a single expression. So essentially this function will return the result of evaluating the when expression directly. So you get rid of the curly braces, you get rid of the explicit return type, you get rid of return, and so you just have this when expression. And in fact, IntelliJ IDEA can help you convert this code into this form automatically. So if you have this when expression and it offers an intention action to what's going on? Lift return out of when expression. So now instead of when something returned, it has turned it into return when something, and then you can convert this into an expression body and delete the return type. And now you can see that just with the 3 simple actions, I have converted the code into the idiomatic form that you have seen on the slide. You can do the same thing with try-catch statements. So in this case, in this example, we have a piece of code that tries to parse a number. If it's an integer, then it returns an integer, and if it cannot be parsed as an integer, it returns null. And once again, we can use the same trick and convert this into an expression. So now we put the equal sign after the function body, remove the return type, and just return this return the individual expressions directly. You can use also, of course, you can use the same trick not just when you need to return a value of from the function. You can use this with assignments as well. So everywhere where you need to calculate some expression depending on whether some exception was thrown or not, you can just use the expression body of the try of try. The next example I'm going to show is shows the use of the Elvis operator. So once again, I have some code that validates the parameters of the function in a way you would do this in Java. So I'm checking I have a person which can have a name or it can have an age, and both of these are optional. And I'm just doing manual checks. So if the person name is null, then I'm throwing an exception. If it doesn't have an age, then I just return. In Kotlin, I can rewrite this shorter. And the way I do it is by using this else operator. So I'm just collapsing this expression into, so I'm taking the name of the person. If the name is defined, I'm taking the name and storing it to the name variable. And if there is no name, I am executing the right-hand expression. And once again, just with when and try, throw and return are expressions in Kotlin, and you can use them on the right-hand side of the else operator. And this is a very concise way of validating function arguments. So now if there is no name, I'm also throwing an exception. If there is no age, I'm returning. And I'm doing this much more concisely than what the code on the left-hand side does. And finally, note that the way the Kotlin construct that I'm using to print this, the name of the age of the person is a string template. So I can embed expressions directly into a string literal. And I don't have a special item for this because I assume this is just something that most people already know how to use. But this is, of course, this is also very idiomatic Kotlin. One other simple example, range checks. So if you need to check that a variable belongs to a range, you can, of course, write just two comparison statements like you would do in Java. But in Kotlin, there is a better way to do this. And once again, let's turn to our IDE to get some assistance. And you see that if you write the same code in the IDE, then it will be highlighted with a yellow underline. And now I'm going to apply the quick fix and convert to range check. And now this has been converted into like a more idiomatic form. So I'm directly expressing the idea that the value has to be in a certain range. And I have the same thing here in the slides. So just so the character has to be in the range from A to Z. The next thing that I'm going to show is destructuring. So Kotlin has, so destructuring is a feature that allows you to declare multiple variables and initialize them with components of something. So I will show some more examples of how this can be used later. And in this example, the components that I'm referring to are the key and the value of the map entry. So once again, this current, the code on the left iterates over map entries similarly to what you would do in Java. So it also does, it is already somewhat better than what you can do in Java, because instead of get entries, get key, instead of like calling get key and get value, it accesses those properties, dot key and dot value. So this is already more concise than what we have in Java. But in fact, Kotlin can do this much better. And I think the IDE can help us as well here. I cannot see anything. Yes. So once again, I'm invoking the quick fix menu. It offers me to use the destruction declaration, and I apply the quick fix. So now on every iteration of the loop, it's automatically unpacking the map entry into the key and the value. And once again, there is something else that the IDE can fix for me. So now I'm using key and value with curly braces inside of the string template. And the curly braces are actually redundant because like these are just simple names and they can be used in a string template without any additional qualifiers. And remove curly braces here as well. So you can see this is much shorter and it's very clear what's going on here. So very, very, very idiomatic. And and yeah, so this example shows like the same code on the slide. So next example, so you can actually so this destructuring, it can be used not with like specific classes, but it can also be used with lists. So what this code does, it tries to split a name of a file into just the name and the extension. And in order to do that, it uses the split function from the Kotlin standard library. And the split function has a limit parameter telling how many pieces it should return at the maximum. So in this case, it will look for the first dot. It will return everything before the first dot as the first element in the list, and everything after the first dot as the second element of the list. If there are more dots, it will just ignore them. And then we're just defining a class to store these multiple values, and we're just returning an instance of this class. So how can we improve this? So this destructuring syntax actually can be used with list as well as like other classes. And in this case, I'm going to so I know that the list has two elements, and so I can initialize two variables at the same time. So I'm initializing the first variable with the first element of the list, and the second variable with the second element of the list. And this is how I do it. So I'm using this the same like destructuring declaration syntax and calling the same split function. Of course, this works only for lists when you know how many elements this will have, and this may not be a very common case in your program, but when you can use this is a very nice pattern to use. So this was the expressions part, and now let's look at what you can do with classes and functions in Kotlin. So as you know, when you write Java, when you write Java, you have to put everything into a method. So when you have a method that when you just need to write some functions that operate on strings, like every project has like functions that do some various stuff on strings. So the way you usually do this in Java, you create a class and you create static methods in it. You like string utils, like this is a very typical name for such a class, and you define just static methods. So in Kotlin, you don't really have static methods as such. Instead, you have members of the companion object. So if you want to define a method that will be accessible through the class itself and not through a specific instance of a class, you make this a member of the companion object. And this is how this looks like in the code. So I'm just using some very simplistic examples. So something is a phone number if it contains 7 digits. Of course, in real life, like phone numbers are much more complicated than this, but we don't care. So how can you do better than that in Kotlin? So the first improvement that you can make is that because this class does not define any instant methods, you can just convert this whole thing into an object. And objects are just that, classes where effectively objects are classes where all members are static. So this is effectively a singleton. But we still have this instance, and we still have to use this instance as a qualifier when we call this isPhone number method. Even though like there is no need to do that actually. So there is no state in this class, there is never going to be any state, so it's just a container of methods. So in Kotlin, in this case, what we can do is we can just define top-level functions. So just put this function directly into the file. So nothing more, no extra wrapping, nothing like that. And because extension functions, like all extension functions, belong to a package. So for example, if we look at this code, this is top-level functions. So you see that this function is declared in a specific package. And this package already acts as a namespace for this function. So we don't need to create an extra layer of namespaces around it. And also this package allows us to disambiguate between multiple functions with the same name. So if in another part of the project we have a different idea of what phone numbers are, and we want to declare the same function to check if the function is a phone number according to the requirements of that part of the project, we already have packages that can be used to distinguish one function from the other. And if we need to use both of the functions in the same file, then we can use imports with aliases to distinguish between them. So we still have these namespaces and namespacing, and we still have the possibility to disambiguate the functions. So like this, and at the same time, we have removed all this boilerplate that does not serve any particular purpose. So can we do better than that? So now we have taken this example of the right thing to do, and we have put it on the left-hand side of the screen. So supposedly there is something that we can do to improve it. And this is in fact true, and we can improve this function by, once again, we can use IntelliJ. So we take this parameter and turn this into a receiver. We are using an intention action for that. Convert parameter to receiver. And after we apply the action, now this has become an extension function on string. So now if we want to call this function instead of like we can just call directly. And inside the body of the function, we can also refer to the members of the string directly. And this is a great approach, actually. So extension functions do not have to represent like some essential API of an object. So if we were defining the API of a string class, of course, we would not put there a method that checks if it's a phone number according to some specific semantics. But you do not need to see an extension functions as part of the class's API. It's just a function that is convenient to use instances of this class in this particular context. And once again, extension functions are defined in a namespace. They have in a package. They have to be specifically imported if you want to use them in a specific place. You can restrict their visibility. So, for example, you can put the private keyword here. And if you do that, then the function will not be accessible outside of the file where it's defined. And so the message here is that don't be afraid of extension functions. So we are using extension functions all over the place in our code bases, and we haven't found any issues with that. They do not actually affect the maintainability of the code. So don't be afraid. Just go ahead and use extension functions whenever you feel like they can make your code shorter and easier to work with. At the same time, one thing I'd like to warn you against is using member extension functions. So you can actually define extension functions inside of a class. And sometimes you can do like the weirdest stuff, like inside a phone book class, you define an extension function, the phone book itself. And this, you can do that. This will compile. I can probably spend 5 minutes explaining the exact semantics of this, but this is just the simple recommendation is don't. So you either define a function inside of this class as a member function, or you define it outside of the class as an extension, like in this example. So this find phone is just a regular method, and this is phone number. We have moved it outside of the class. Now, if the extension function doesn't need to have access to members of this class, it's okay to keep this inside. And also, if you are defining a DSL, that it can be extremely useful and extremely convenient to define member extension functions inside of a class, and then by all means do it. But if you are not defining DSLs and don't need for a function to access the members of the class, then just put it outside. And once again, the private keyword gives you a possibility to restrict the scope. So this function will be visible only inside this file, and you should not need to worry about like other places in the code accessing the logic that you don't want them to access. And extensions, like this is one more recommendation to use extensions all over the place. And the idea here is that we have this. So we have this class. So this is a very simple class. It has just two properties and two like actual properties and one calculated property. And you should imagine here a much larger class for this recommendation to make more sense. So imagine that you have an like open class which has 20 methods. So it has like 50 methods. 20 of them are meant to be overridden in subclasses, and another 30 are just utility methods that you want the users of this class to have access to, but they don't actually need to be overridden in subclasses. And what you should consider doing in this case is just converting all these non-essential things into extensions. So when you have a class with 20 methods that need to be overridden, it's much easier to understand how exactly you should override them and what you should do with them. And at the same time, the users of this class can still have access to like comprehensive API, which is provided as a set of extension methods. So, like, this recommendation is something that you should not just blindly follow in all cases. So you should actually make a call whether. So, for example, if you want the API to be usable from Java, then it actually makes sense to have regular methods rather than extension methods because they are somewhat easier to call from Java. But in pure Kotlin project, that is something worth considering. The next thing that I'm going to talk about is emitting return types. So I've already mentioned functions with expression body, and in this case, so we have a Java interface, we have a Kotlin class that implements this interface, and it defines, so one function it defines by itself, and another function it overrides from the Java code. And in this case, I have specified the return type for the pure Kotlin method, and I have not specified the return type for the Java method. And this is actually exactly the wrong way to do this. So for the Kotlin code, there is actually no sense for the pure Kotlin method. There is not much sense to specify the return type because it's absolutely clear. So we are returning a string literal, so that the return type. This means that the return type is string. On the other hand, for the Java method, it's much more important to specify the return type explicitly. And the reason why is that in the code on the left, you will have a method returning a so-called platform type. And this has to do with nullability. So when we have a Java method which returns an object, in Kotlin, we do not know whether this Java method can return null or not, or cannot return null. So we are treating this as a platform type. Platform type essentially means type with unknown nullability. So it can be null, it can be not null. If we want to check for null, we will not highlight it as redundant. If you don't check for null, we'll assume that you know what you are doing. So now let's look at what happens when you implement a method of returning a platform type in a Kotlin interface. In this case, we have a Kotlin class. So people who work with your class assume that it has proper nullability information. So if a method is not marked as returning a nullable value, then it can never return null. But we are still implementing a Java interface. So the nullability of this method is still not known. So the callers of the class will not be required to check for null. But on the same time, the method can actually return null because this is what the Java context says. In this case, it's much more important to actually specify the return type explicitly. In this case, I'm specifying that the method returns string ? And this requires the Kotlin callers to always check for null, which is the right thing to do in this case, because the method can return null, because I'm implementing it as returning the value of a system property, and the system property is not necessarily defined. So the null can be returned. And IntelliJ IDEA also warns you about this case. Oops. Wait. Yes. Oops. So this highlights this method as a warning. It shows that declaration has return type from. This is actually a different case, but whatever. So it shows that the type is inferred, and we have to specify this type explicitly. Specify return type explicitly. And now we specified it. Now we can choose whether this is actually whether it's actually a string or a string ? And we can enter the string ? And now this will be happy. Let's go back to the slides. So the next recommendation is also a fairly obvious one. So in Kotlin, you can define default parameter values for methods. And when you define it in Java, you don't have this possibility, so you very often create large groups of overloads for methods which do the same thing, but which can be called with different number of parameters. So in this case, I have a phone book, it can be printed, there is some default separator, and I can specify a custom separator if I need to. And the Java style to do this is to define two methods, and one of the methods will call the other method, and the other method will actually continue the logic. But in Kotlin, you can do better than that. You can define one method, you can define the separator, and you can define the default value for this separator. In this case, the separator is a comma. And this allows to call the method with no parameters and with one parameter as well. And also note that I'm doing one other very useful thing here. So I'm specifying the name of this parameter when I call the method. So you can do this every time when you call the Kotlin method. It doesn't matter whether the parameter has a default value or not. You can always do that. And this is actually a good idea to do this when you call a parameter that has a call a method that has a parameter of the primitive type, because this makes it clear what this thing is. So like this pipe character, like what meaning does it have? What is it used for? It's not always clear just from looking at the code, but if you make this explicit that, okay, this is a separator, then someone who reads the code will see it and understand this much more easily. Next example. So the next example talks about something called late unique properties. And this is once again about nullability. So Kotlin, just like Java, normally requires you to initialize all final fields in a constructor. So this is actually a requirement of the JVM. So if we have a state, for example, this is a test that has a state, and I have to initialize it in the constructor. And I cannot initialize it in the constructor because I don't have the necessary information. Or in this case, this is unit test, so I have to initialize it in the setup method. And so, because I cannot initialize it in the constructor, the only value I can provide as the initializer is null, so I have to mark this as a nullable. And this is not very nice because every time I access this field, I have to use these ugly double bang characters, which is a sign that I'm doing something wrong, and those should be avoided whenever possible. So how can I do better? I can do better by declaring this as a late unique property. And late unique property tells that even though I cannot provide a value at construction time, I guarantee that the property will be initialized with a non-null value at a later point in the life cycle of a class. So in the case of for example, in the case of an Android activity, this will be the onCreate method. In the case of a JUnit test, this is the setup method. And because I guarantee that the property will be initialized, I can actually, the compiler lets me access this property without an explicit null check. So I can just treat it as a value of a non-null type. And if it turns out that I have lied and I have not initialized the property before I try to access it, then I will get a non-type exception. So there's always, you should only use late unique when your class has a very strictly defined lifecycle, and it is actually guaranteed by the logic of the code that this will be initialized. But yeah, this is a surprisingly useful trick that comes up in many different situations. In the next example, I will talk a little bit about mutability and data classes. So in Kotlin, in Kotlin you can use this like the same programming paradigms as in Java. In Java, it's very common to create classes with immutable fields. For example, I have a person. The name of this person is defined at birth, but the person can get older at some point in time. So I have defined the name as a final field, so like val property means final field, and the age property is not final. And so when the person gets older, I'm just incrementing the age of this person. And this is perfectly fine in some cases, but in other cases, it's better to have immutable data. So it's better to represent mutations by just creating a new instance of the object in a new state, making sure that this new state gets to the right place, and just abandoning the object with the old object. And Kotlin has a great tool that helps you work with such objects, and this is the copy method. So the copy method is one of the methods that is generated by for you by the compiler when you mark the class's data. So in addition to the equals and hashcode and toString methods, which all data classes have, they also get some other methods, and one of these methods is the copy method. And this copy method allows you to create an instance of essentially the same object as this one, but with some properties changed to other values. So in this case, I'm changing the age to age plus 1. So I'm getting a new person, which is with the same person, but 1 year older. And I'm not mutating the original person. Like whether this makes sense in the design of your system or not, this is something for you to decide. But if you can't have the immutable data, then this copy method is a great way to help you get immutable data. Finally, one more just so one more syntactical tip. So in Kotlin, you very often work with functional types. So for example, if you have an event handler in Java, you would define an interface representing the event handler. In Kotlin, you can define a function type directly. So like the event handler is something that takes an event as a parameter and returns unit, which is the Kotlin's way of saying that it does not return anything. And if you start working with such handlers, it can get quite verbose very often. So you have to repeat those declarations of handlers like over and over again. And starting with Kotlin 1.1, there is a new tool that helps you deal with such declarations. And this tool is called type aliases. So what I can do is that I can say that whenever I say click handler, this actually means a function that takes an event and returns unit. And I'm just replacing all of the usages of click handler with this type alias. And I don't even have to do this myself, so I can actually use the ID for that. So for example, here I select this type, and I invoke the refactor. Is it in the context menu? No, it's not in the context menu. Refactor extract type alias. So I'm entering the name for this event handler. Okay. And IntelliJ actually automatically detects another use of the same type in this class and offers me to replace it. And I accept the suggestion. And so now I have a type alias which is used in some places in my code. And if I decide that like this doesn't actually make sense, I'm using this in only 2 places, then I can actually do the opposite and inline this. So I'm just invoking the regular inline refactoring. It asks me whether I want to actually inline this type alias, and I say yes. And now the type alias is gone. So like this is very handy to work with this concept. So functional types are just one of the cases where this can be useful. So there's also, for example, the case of collections. So when you're defining a collection type, you have to specify type arguments. And if it's something complicated, like a map from a person to list of strings, where strings are like addresses where this person lives or something like that, you can define a shorter name for this. So you can define like type alias person addresses equals like this thing, like a list of map of something into a list of other things. And this can also be used to make your code much shorter. Now, of course, the trade-off is that sometimes this can make the code somewhat more difficult to understand, but usually it's not a big deal, and you can use type aliases when you need to. Next example is using data classes to return multiple values from a function. So the Kotlin standard library has this pair class, which is essentially a pair of two arbitrary things, where there is like no name or anything. It's just 2 things linked in a single object, and which things and the types of those things are specified as type parameters in the declaration of the pair. So here I declare a function that returns a pair of integer and a string, and I'm using the very handy to function, which creates a pair of any 2 objects. And now when I call the function, I'm just taking the first and the second element of this pair. And the downside of this is that it may not be clear for the caller of the function what those things actually mean. So like, what's the first element in the pair? What's the second element in the pair? What's the semantics of those? And instead of using the pair class, it's very often beneficial to declare a specific class for this case. So defining classes is very easy in Kotlin, so you don't have to put every class into a separate file. You can define a class defining a class just takes as many lines as there are properties in this class. In this case, there are just 2 properties, so it's very easy to define like a name number. So there's a number in the name of this number. And now I'm just returning this name number, and it becomes, for a caller of this function, it becomes much clearer what the semantics of those are. And when I call this function, I can actually unpack the values into the number and the name very easily, once again using this destructuring declaration syntax that I showed previously. And I can use this thanks to the data class declaration. So I cannot use destructuring declarations with an arbitrary class, but I can use them with the data class, or with classes that define this component 1, component 2, and so on methods in another way, like this is the case with lists. So I have given names to those things. It's very clear what exactly the semantics of those things are, and the API is clear and easy to use. And we have not used that much code to make it clear and easy to use. So now let's look at some of the standard library functions that can help you write code in a more idiomatic way. So first of all, like a very simple example. So we have to update a progress indicator, and the value of the progress indicator has to be between 0 and 100. And I have written a very nice function that uses a when statement in Kotlin to clamp the number into the correct range, and this actually looks not that bad. So this is like nice Kotlin code, but this code actually does the job that is handled by a standard library function. And it's very easy to use. So I'm just using the curse in function, giving it the minimum and the maximum value, and the new value is guaranteed to be within that range. And also there are curse at least, curse at most functions if you just have to constrain the value from one side, not from two sides in this example. The next example shows the apply function. When you are it's a fairly common thing to create an object graph from code. So in this case, I'm creating a swing component, but this comes up in all kinds of different situations. Like you have to create an object, you have to define properties for this object, you have to maybe add other objects to it as children or as elements in the container or something like that. And then you need to return it. And the left-hand side shows like the regular Java style way of doing this. And in Kotlin, you can do better. You can use this apply function. An apply function takes the block of code and inside as a parameter, and inside this block of code, you can directly access the properties of the object on which was on the left-hand side of the apply. So in this case, I have this label. It's on the left-hand side of apply, and so this assignments to properties inside of this block, like foreground and background, they are just assignments of properties of this object, of this label. And the return value of apply is the very object on which it has been called. So this allows me to just directly, once again, to convert my function to the expression body syntax, which is always a good thing, almost always a good thing in Kotlin code. And I can emit the return type, and all in all, the code becomes quite a bit shorter and clearer. And there are some other functions that also let you execute code, or like accesses. That allow you to avoid repeating the same receiver, like with and run, but I'm not going to show that here. Now there is another thing, like one other useful tip is this filter is instant function. So it's a very common task that you have a list of objects and you need to find out the object of the right type. And of course you can just use a regular filter function. So pass in a lambda, and inside the lambda check that the object has the right type. So in this case, check that it is a string. And the problem is that so if we move to IntelliJ, and if you look at this code, even though that we have checked that the object is a string, this is not actually reflected in the type. So if I'm using this, if I use the intention action to, so there's a feature called type hints, and the IntelliJ IDEA can now show the types of everything that is in the editor. And if I enable showing the return type hints, the IntelliJ will show me that this function actually returns a list of any. So even though we have checked the type of the object, it is not actually reflected in the return type of the function. So the compiler does not realize that we have performed the type check here. And the filter is instant, and what we can do instead is we can use the filter is instant function. And as you can see, with filter is instance, we are passing the type that we need as a type parameter for the call, And as you can see, this actually does affect the return type. So in this case, now we have a function which returns a list of strings, which is what we expected from originally. And in the same case, if you have in the same way, if you have a list of nullable values, you can use the filter not null function to take the nulls out of the list, and this also affects the return type of the collection. So back to the slides. So so yeah, you use filter as instance and you pass the type as a type parameter. And the interesting part is that this type, so even though in Java, so and there is a similar case is the snap not null function. So it's a very common case that you have a collection of objects and you apply a function to those objects, and the function returns a value for some of the objects and returns null for other objects. And you can of course deal with that by just calling list all errors. So in this case, I'm just calling map. It returns a list of nullable strings, and then I'm using the filter not null function that I mentioned previously to take the nulls out. But actually, you can very easily combine the calls. So instead of map and filter not null, you can just use this map not null method, and it does exactly the same thing. The next thing I'm going to talk about is comparing objects. So I have a list of persons that can be compared by name and age. And this shows how you can implement this comparator like in regular Java style code. So I'm comparing the name first. If I got a value which is non-zero, then I'm returning it, and otherwise I'm comparing the ages. And this is logic. This is something that I can make a mistake. I can confuse which way the comparison should be performed or something like that. And this is there is quite a lot of code. And I can do this much more easily using the compare by function. So the compare by returns a comparator, and this comparator compares by evaluating each of the parameters I pass to it in sequence until it finds some parameter for which there is a difference. So the semantics of this code is the same. I'm comparing the names first. If the names are different, then if the names are the same, I'm comparing the ages. But the way I express this is much more natural. It's much more clear that what's going on here. It's much more clear that there is no mistake in the logic, unless the Kotlin standard library is broken, which it isn't. And so this is a very, very easy way to perform complicated comparisons, complex comparisons. The next function that I'm going to talk about is group by. So this is very useful. For example, I have a collection of requests. I have to analyze what requests are there for each distinct URL. And so the example shows some fairly involved piece of code. So I'm creating a map from a string to a list of requests. Then I'm going through all of the requests, and I'm using this get or put function to make sure that if there is no existing list of requests for this URL in the map, then I'm creating a new list. And then I'm adding the new request to this map. So this is also this example also shows some useful tricks, like how you can use this get or put function. But the way, the thing, what this code does is actually a very roundabout way of doing a very simple thing, of doing a grouping. And in the Kotlin standard library, there is a predefined function that does the grouping, and you can simply pass the criteria to group items by as a parameter to it. I'm just saying group request by URL. And it will return the same thing. It will return this map of string to list of requests, but much more concise and much more easy, much more easily readable. And finally, the last trick I'm going to show is how you can use Kotlin string methods for string parsing. So let's suppose that I want to split a path into a directory and a file name. And in this example, I'm using regular expressions for that. And everyone knows regular expressions. Everyone reaches for them whenever they need to perform a string parsing task. And Kotlin has a very nice API for working with that. And this example shows how you can use it. So I'm defining a pattern, pre-compiling it, And then I'm using to match the match entire method, which tries to match the entire string against this pattern. And if the match succeeds, then I'm just taking the first and the second groups in the results and returning them as the direct randomness. And this is nice, and this is very flexible, and you can do a lot of things with regular expressions. But this is also like fairly complicated. So, and the task that we are solving is actually very simple. So we need just to split on the first slash and take everything before it and everything after it. And so we can use, for example, the split method that I was showing previously. Or we can use a different method, which is somewhat a better fit in this case. So I'm using the substring before last and substring after last method. The substring before last method returns the substring before the last occurrence of this character. So this will be the path, and the substring after the last occurrence of this character is going to be the final. And another thing that is I'm doing to make this work correctly is passing the default value for the case when there is no slash. So when there is no slash, these functions by default return the entire string. And this is not what I need in this case. So in this case, I need the directory to be empty and the name to be the entire string. So I'm passing the empty string as a parameter, as a default value parameter to the first function. So if the string is A, then the string before last will return the empty string because I have passed it as a default value. And the string after last will return just the entire string. So this concludes the list of tips that I was going to show. And if you want to know more about how to write idiomatic code in Kotlin, you can check out the book that I wrote together with my colleague Svetlana. And it also gives quite a few examples of different ways of using Kotlin idiomatically. And you can also come to the Kotlin Conf in San Francisco in November, and there will be my talk there about idiomatic Kotlin, and also Eugenia, who's doing another presentation today, will also have a talk there. And like this is going to be a great event, and we will be really happy to see you there. So if anyone has questions, then feel free to ask. Это как раз 45 минут. Так, сейчас я тогда выключу всякий стриминг.